In this video, we will work through two problems that are more complex and involve the process of squaring or cubing a length measurement in order to create a new conversion factor. So we're going to work together, and I want you to work along with me and see if you can kind of follow what it is that I am doing. So if you look at this problem, it's talking about, both problems here are two kind of large landmarks in North Carolina, one being the Biltmore Estate and one being Pilot Mountain. And so the original Biltmore Estate contained approximately 125,000 acres of land. If an acre is 4840 square yards, calculate the size of the estate in square meters. And so if you notice, you see some length units, but they're in terms of area, and acres is an area unit. And so whenever you see a length unit and you see a squared or a cubed, what you want to do is still use what you already know about the length, but we can alter how many dimensions there are for that equality just by adding squareds or cubed to the equality that we write down. And so we're going to work through this problem, and we have to first pick out what it is the measurement is asking to convert and what the measurement is. And so we have two numbers here. We have 125,000 acres, and then we also have an acre is 4840 yards squared. And so the question is asking about the entire estate. And so the 125,000 acres, that's the size of the estate. The 4840 yards squared, it's in the same statement as an acre. And so this is a given equality. And so I want to take this information and I want to kind of rewrite it so that we don't consider the 4840 square yards as being the measurement that we start with. And so an acre is 4840 square yards. So what that is saying is that one acre is 4840 yards squared. Okay, so we want to start with the 125,000 acres. That is going to be our given measurement. 125,000 acres. So our first conversion factor will involve getting rid of acres. And the conversion factor that I just wrote down has acres. So whenever you have a unit and you want to get rid of it and you were given a conversion factor with that same unit, that is when you want to use that. And so I'm going to write down precisely what I had written down there, which is 1 acre is 4840 yards squared. So this equality here, it already has yards squared in it. So yards squared is the unit that I want to get rid of, but I don't know anything except for acres. I don't know anything about yards squared, but I do know about yards. And you always want to use what you know. And so the only thing really that I know about yards is that there are 3 feet in 1 yard. But I don't want it to be one dimension. 3 feet in 1 yard is one dimension. I want it to be squared. And so everything I just wrote down, I need to square it. And the only thing I wrote down was the 1, the 3, and the feet. So I need to square this equality. And so you square the unit and you square the number because the number is attached to the unit. So I need to square the 3 and I need to square the feet. So now I want to get rid of feet squared. Now, I don't know anything about feet squared, but I do know about feet and inches. And I'm going toward inches because I want to go into the metric system. And so there is 1 foot is equal to 12 inches. but I don't want it to be one dimension. I want it to be two. And so I'm going to square the number and the unit. You have to square both. Okay, so now I've got inches squared. Don't want inches squared, so I'm going to get rid of inches squared. So now I've got to think about what I know about inches. And whenever we get to inches, that's when we can actually convert over to the metric system. And so we can write down what we know about centimeters. So there are 2.54 centimeters in 1 inch, but we want it to be squared, and so we need to square everything. Okay, so now I've got centimeters squared, but I want it to be meters squared. So I'm going to get rid of centimeters squared, and I want to go to meters, but I don't know anything about meters squared and centimeters squared, but I do know about centimeters. There are 100 centimeters in 1 meter, but I need it to be squared, and so I need to square the equality number and the unit to make it be two-dimensional. So now you can go back through and you can cancel out the units. And that's what I was kind of walking us through as we went. That's the reason I put acres on the bottom, was because I wanted it to cancel. And I put yards on the bottom. And so we got feet squared and inches squared and centimeters squared. And everything, all these units will cancel, leaving with meters squared. So now all I need to do is do the stuff associated with the numbers, because the units are canceled. So I need to rewrite the number in terms of meters squared, but I need to do all the math that is outlined. And so I have the units and I have the number, and I made sure that whenever I made it go from 1 dimension to 2 dimension, that I squared the number so that when we canceled it, you would still see the squared. So I'm going to do precisely what I wrote down. So I wrote down 125,000, and so I'm going to use that number, and then I wrote down 4840, so I'm going to use that number. But the next number that I wrote down, I want that number to be squared. And the next number, 12, I want that number to be squared. And then the next number that I wrote down, 2.54, I want that number to be squared. And then I want to divide by, there's 1 squared is 1, 1 squared is 1, 1 squared is 1, 100. So I need to divide by 100, but I need it to be 100 squared. And so my answer ends up being this large number here, 505,857,052.8. And so I'm going to type that number in. So 505,857,052.8 meters squared. That is a lot of digits. And we did not start off with a lot of digits. So 125,000 acres is the starting measurement. So we have to think about what that's trying to tell us. And whenever you don't have a decimal point, the last non-zero number is the end of your significant figures. So the 5 is our last non-zero number. That is our estimated position. Those 3 zeros are there just as placeholders to tell you that it's 125,000 acres and not 125. But it's just 3 significant digits. So we need to round to 3 digits. So we have 3 significant figures here. So we need to round to 1, 2, 3. So we need it to be 506, and then we still need it to be a really large measurement. So we need a bunch of placeholder zeros. Okay, so 505, and then for the 506, because we'll round up, and then where the 8 was, I'll put a 0, where the 5 was, I'll put a 0, where the 7 was, I'll put a 0, where the 0 is, I'll put a 0, and the next 5 a 0, and the next 2 a 0. So this should still be 1, 2, 3, 4, 5, 6, 7, 8, 9 digits from the decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9 digits. Okay, so it still means the same thing, but now it is just 3 significant digits, and it's meters squared. You can also write it in scientific notation. So you could write it as 5.06 times 10, and then you have to count how many places you moved it. So move it 1 place, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 positions. And that's 3 significant digits. And then the unit is meters squared. Meters squared. So either one of these two answers, either in standard form or in scientific notation, either one of those is correct because they both are just 3 significant digits. Our next one involves cubed, and so it involves a volume. And so Pala Mountain, it gets its name because of it being a large exposed rock on top of the mountain. And so this rock has a density of about 2.65 grams per centimeter cubed. Whenever you see the diagonal, that is an indication that that is a conversion factor, not a measurement. So I'm going to rewrite the density of the rock as 2.65 grams per 1 centimeter cubed. So the relationship between volume and mass. Okay, so density that's given to you is a conversion factor. If the knob is a cylinder and it has a height, so let's just draw okay, so it has a height of about 160 feet and a diameter of 330 feet. How many tons of rock make up the large pinnacle? And so we need to use these dimensions and find the volume. So a cylinder, the volume for a cylinder is pi r squared h. And so we have the diameter. So we got, I'm going to clear here. So we have the diameter 330, and we're going to divide that by 2 to get radius. And then we're going to square it because that's the radius. And then we're going to multiply by 160 feet, which is the height. And then we're going to multiply by pi. And I'm not going to write 3.14. I'm going to actually hit the pi button. We have scientific calculators, and you need to use the pi button on the scientific calculator. Okay, so we get this really large volume, and that makes sense because this would be cubic feet, because feet squared times feet would be feet cubed. And all of these, both of these measurements are just 2 significant figures. So I'm just going to take this volume and I'm going to round it to 2 significant figures. Okay, so we've got 13,684,777, and then it just keeps going and going and going. I just want it to be 2 digits. So that would be these first 2 digits here. So that would be 14 million cubic feet. So my starting measurement is the volume that I just calculated using the measurements that I was given. And so that would be 14 million feet cubed. Okay. So whenever you have length measurements, feet, inches, centimeters, meters, you want to use what you know about the one dimension. And if it's area or volume, then you're going to square or cube the equality that you write down. So the first thing, you just want to write down the equality. And feet, you're going to go to inches. And so we want to cube our equality. And so 1 foot cubed. So 1 cubed, feet cubed. And then you have to cube the number and the unit for inches. Cubed. Many people just put this in parentheses, but I'm going ahead and distributing it to the number and the unit so that it doesn't get lost when you cancel out the units. Okay, so whenever you're in inches, if you're wanting to go to the metric system, you go into centimeters next. So you want to write down what you know about the relationship between inches and centimeters. 2.54 centimeters, same thing as an inch, but I need it to be 3 dimensions, and so I need to cube everything. So I'm going to cube the numbers and to cube the units. And then I want to get rid of centimeters cubed. And you should notice right here, our density is versus centimeters cubed. So as soon as your unit that you want to get rid of matches a given equality, you want to use that given equality. So right now is when I use this. And the centimeters cubed is already part of that conversion factor. So I'm not going to cube anything because it's already there. So the volume of 1 centimeter cubed is the same thing as 2.65 grams of rock. And so I want to get into tons, and tons in terms of pounds. So grams, again, you kind of get used to doing the same kind of conversions over and over again. Go from grams to kilograms. So there's 1,000 grams in a kilogram. And then you can go from kilograms into pounds. And once you've used it a few times, it makes it easier and easier to use. Move these over so I can have room for another conversion factor. And I need to go from pounds. There are 2,000 pounds in a ton. And that's how much weight it is in the unit of tons, and that's the unit that I want for my answer. And so we can go through and we can cancel all of the units to make sure that we haven't overlooked something. So I'm just going to use a line. Okay. And so I can cancel feet cubed because it's on top and bottom. And then I've got inches cubed on top and bottom, and what I've written down is the correct equality. So I can cancel out inches cubed. And I can cancel centimeters cubed because it's on top and bottom. And I can cancel grams because it's on top and bottom. And kilograms cancels out. And pounds will cancel. leaving us with tons. So now we just need to do the math. And this, if you want to get rid of the units and just leave one unit, and to express it in the correct answer, you've got to do all the arithmetic associated. So that's why I put, when I want to cube a number, it's on the number already and my unit is gone. The number and the unit are separate entities. So I have the cubed on there. I don't have this first one cubed because it's already a volume. So 14 million, 14 and then 6 zeros, 1, 2, 3, 4, 5, 6. Okay. And then I'm going to multiply it by 12, but it has to be cubed, so I'm going to cube that, times 2.54, and I need to cube that, times 2.65, don't cube that because there's no cubed there, and then times 2.205, and then I want to divide by 1,000, and then divide by 2,000. Okay, so I get a little more than 1,000,000 tons. So I'm going to type the answer that I see, 1158,236.89, and then it just keeps going, ... and that's tons. Okay, so that is a lot of digits. I only want 2 digits. My measurements up here are 2 digits, the 330 feet and the 160 feet. Those are the measurements, and I use that to get to the volume, and then I use the volume to get to the weight. And so this here I need to go to 2 digits, so we do the first 2 digits, and so I'm going to round it to 1 and then a 2, and then all of the numbers that go before the decimal I need placeholder 0, so where this one is a 0, and then where the 8 was is a 0, and the 2 is a 0, and the 3 is a 0, and the 6 is a 0, and then tons. And so this still should mean 1.2 million. So you can write it with all the placeholder zeros, or you can put it in scientific notation. So you would move it 6 places, 1, 2, 3, 4, 5, 6 places, and then you would put the units. And so either one of these would be correct because they are rounded to 2 digits based on your measurement that was given, the 330 feet and the 160 feet.